Welcome to Bethlehem Academy. In this section, we are going to look at current electricity numericals. We will look at Selena solutions, exercise 8a. The first question talks about, in a conductor, 6.25 electrons flow from its end A to end B in 2 seconds. Find the current flowing through the conductor, that is E is equal to, and given E is equal to 1.6 into 10 power minus 19 coulombs. This question is very easy. All that it says is there is a conductor, and in that conductor from end A, let's say this is end A and this is end B, from this end A to end B, these many number of electrons are flowing. When they are flowing, it is also given that they are flowing in a time period of 2 seconds. When they are doing so from end A to end B, then what is the current that is flowing through the conductor? This is basically testing the concept of definition of current. The current is nothing but the rate of charge flow. That is, the current is equal to nothing but rate of charge flow. Rate of charge flow, that means Q by T. So if you know this formula, and then you will be able to solve this question very easily. Let's write down the information that is given. It is given that N, that is the number of electrons that are flowing across the conductor, are 6.25 into 10 power 16, and also they are flowing, the time taken by them is T is equal to 2 seconds, and then charge on each electron is equal to 1.6 into 10 power minus 19 coulombs. So we know the definition of current, I is equal to Q divided by T. Q is nothing but the NE. Q is also nothing but NE, that is, charge is nothing but number of electrons into charge on each electron, isn't it? That is nothing but the total charge. Total charge is equal to each electron has charge, and there are n such electrons which are passing from one end to another end. So your total charge is equal to number of electrons multiplied by E. So I is equal to Q by T, that is equal to NE divided by T. Substituting the values for NE divided by T, N is equal to 6.25 into 10 power 16, E is equal to 1.6 into 10 power minus 19, T is equal to 2 seconds, and then we will get, when you simplify all of this, you will get 5 into 10 power minus 3 amperes, or 5 milliamperes. So 10 power minus 3 is nothing but milliamperes. So that is the answer. The next question talks about a current of 1.6 milliamperes flows through a conductor if charge on an electron is 1.6 into 10 power minus 19 coulombs. Find the number of electrons that will pass each second through the cross section of the conductor. Here also we are going to use the same formula, that is I is equal to Q by T, or that is equal to Q is equal to NE, so that is equal to NE divided by T. If we are comfortable with this formula, then all that we need to do is we need to just substitute the information that is given. We are given current that is equal to 1.6 milliamperes, or 1.6 into 10 power minus 3 amperes, that is equal to N is not given, that is what we need to find out. And then E is given as 1.6 into 10 power minus 19 coulombs. The time taken for all these electrons to flow through is equal to 1 second. So on substituting all of them would give us a value of N is equal to 10 power 16. The next question talks about, find the potential difference required to pass a current of 0.2A in a wire of resistance 20 ohms. Now this question is testing the concept of Ohm's law. If we know Ohm's law, then this is nothing but a cakewalk. First thing that we need to do is we write down the information that is given. What is the information given to us? Information given to us, I is equal to 200 milliamperes, or 200 into 10 power minus 3 amperes, that is nothing but 0.2 amperes. So resistance is given as 20 ohms, and V is what we need to find out. According to Ohm's law, we know V is equal to IR. So substitute the value of I and R in the formula. So I is equal to 0.2 and R is equal to 20, and then V is equal to 4 volts. The next question, an electric bulb draws 1.2 ampere current at a 6 volts. Find the resistance of the filament bulb while glowing. Again, write down the information that is given. I is equal to 1.2 amperes, V is equal to 6 volts, and R is what we need to find out. Again, it is based on the Ohm's law, so V is equal to IR. V, we are already given 6 volts, I is given as 1.2 amperes, and R is what we need to find out. So then R is equal to 6 divided by 1.2, that is equal to 5 ohms. Next question is, a car bulb connected to a 12 volt battery draws 2 ampere current when glowing. what is the resistance of the filament of the bulb? Will the resistance be more same or less when the bulb is not glowing? Write down the given information. V is equal to 12 volts and I is equal to 2 amperes. We need to find out R is equal to how much. So that is equal to, we need to find out R is equal to how much. This is the information that is given. So what is the formula that relates all these three? It is nothing but the Ohm's law. V is equal to IR. So substitute V is equal to 12 and I is equal to 2 and R would become 6 amperes, 6 ohms. So will the resistance be more or less when the bulb is glowing, when the bulb is not glowing? When the bulb is not glowing, then the resistance would be less. Next question is, calculate the current flowing through a wire of resistance 5 ohms is connected to a battery of potential difference of 3 volts. Write down again the information that is given. R is equal to 5 ohms, V is equal to 3 volts and I is equal to how much. So all the formula that connects all these three is equal to V is equal to IR. We substitute the values. V is equal to 3, I we do not know, that we need to find out, and R is equal to 5. Then I is equal to V by R, that is equal to 3 by 5, that is equal to 0.6. In an experiment of verification of Ohm's law, following observations are obtained. The potential difference, that is voltage, and then I are recorded as given in the table. Then draw a characteristic VI graph and use this graph to find out the potential difference V when the current is 0.5 amperes, when the current I, find out the current I when the potential difference V is equal to 0.7 volts and resistance in the circuit is equal to how much. This is a very easy question. All that you need to do is take a graph paper. I have done it here with the hand, but you need to take the graph paper and represent V on y axis, I on x axis, because it is given as VI graph. So then plot 0, 0.2, 0.4, 0.6, 0.8, 1, 1.2, the values corresponding to 0.51, 1.52, and then at 2, 0.2, and then it is 0.5, and then it is 0.4, it is 1, and then at 0.6 the value is 1.5, at 0.8 and then the value of y is equal to 2, and then at current is equal to 1, then the value of voltage is equal to 2.5. So when you draw a graph paper, every point falls on just a straight line, and then once you have that information, then you can find out the potential difference when the current is equal to 0.5 amperes. Now current is equal to 0.5 amperes, take this 0.5 line and then find out the voltage. That means you need to read the value that is on the y-axis. So this would be the voltage that corresponds to 0.5 amperes. Similarly, what is the current? What is the current when the potential difference is 0.75 volts? Take 0.75 volts of potential difference, that is equal to this 0.5 and this 0.75. So from here you draw a straight line and then drop the line, vertical line, onto the x-axis. So this would be the current that corresponds to this value. So reading is easy, but the tricky part probably would be calculating the resistance. The resistance will be calculated by using the formula V by I, or the slope of the graph. So if you have a graph, you can find out the slope of the graph. That slope of the graph in this case turns out to be resistance, because we know that when we draw a graph between V and I, the slope of the graph would be resistance. So to find out the resistance, we need to simply find out the slope of a straight line. How can we find out the slope of a straight line? We know the formula for finding out the slope of a straight line is equal to y2 minus y1 divided by x2 minus x1. What is y1? What is y2? What is x1? What is x2? So for example, if I take this point as first point and this point as second point, and then this would be x1 y1 and this would be x2 y2. Using these 2 points, I can find out the slope of the straight line, or I can also consider this as point 1 and this as point 2, and using these 2 points I can also find out the slope of the straight line, and or I can even use these 2 points, or I can also use these 2 points, or I can use even these 2 points. I can use any 2 points to find out the slope of a straight line. Here I am taking first 2 points, that is this is 1 point and this is second point. So when I do that, my y2 minus y1 is equal to 1 minus 0.5, x2 minus x1 is equal to 0.4 minus 0.2. That will give me 2.4 ohms as the resistance. The next question talks about two wires of the same material and same length have radii R1 and R2 respectively. Compare their resistance and their resistivities. This is an important question. This question was asked in the previous year board question. So please pay attention. So here all that we need to do is two wires of the same material and the same length have radii R1 and R2 respectively, and then compare their resistance. So here what we need to do is we need to know, first of all, the resistance is given by the formula R is equal to rho times L divided by A. So this formula if we know, then we will be able to solve this concept. What is it told? It was given to us that they belong to the same material, that is same material and the same length. So length is same and then radius is different, that means effectively A is different. So then compare their resistance. How do the comparison of the resistance will be? So we know that resistance is inversely proportional to the area, that is 1 by A. From this equation we know resistance is inversely proportional to 1 by A. So R, since these are length, so the area of a cylinder, this is a cylindrical wire is in the form of a cylinder. So we know that pi R square R, we know that resistance is inversely proportional to 1 by R square. That means R1 by R2 is equal to R2 square divided by R1 square, because R1 is proportional to R2 square, then R2 is proportional to R1 square. R, it is inversely proportional. So R1, if the R1 is in the numerator, if resistance is in the numerator, the radius will be of the corresponding radius should be in the denominator, because both of them are inversely related. So I will get R1 by R2 is equal to R2 square by R1 square. This is the relationship that we need to get. What is the ratio of their resistivity? The ratio of resistivity or specific resistance is same. Why is it same? Because our resistivity does not depend upon our length, or it does not depend upon cross-sectional area. Resistivity or a specific resistance is only a function of the material. Very, very important point. This point will be tested again and again in ICSE. So if your material is same, then the specific resistance will be same, because specific resistance is a material property. It does not depend upon any dimensions. So since the material is same for these two wires, so the resistivity, specific resistivity is same, or they will be in 1:1 ratio. The next question is, a given wire of resistance 1 ohms is stretched to double its length. What will be its new resistance? So here we need to write down L1 is equal to L, and then R1 is equal to 1 ohm. Then L2, that is equal to the length, final length, that is this initial wire is stretched to double its length. So that is equal to 2L. We need to find out R2 as how much. That is the information that we have, and this is what we need to. So what I am going to do in this equation is, I am going to multiply the numerator and the denominator by L. So when I multiply numerator and the denominator by L, I will get rho into L is equal to rho L square, A into L is equal to volume. Then R1 by R2 is equal to rho into L1 square divided by V1, rho into L2 square by V2. But I know my initial volume and final volume are same, because after all I am stretching the length of a wire. So for example, if I have a wire of this much of cross section, and then when I stretch that wire, so what will happen is its length will increase, but at the same time its cross sectional area will decrease, but however overall volume will remain same, because the material is not lost. So we are considering the fact that when it is stretched, when the length is doubled, its cross-sectional area also needs to be taken into account. That is why we are multiplying with L and dividing with L and taking out the volume out of the equation. So when we take out this V1 is equal to V2, this will go, and since the same material, resistivity also will go. So then R1 by R2 is equal to L1 square by L2 square. You know that R1 by R2 is not equal to L1 by L2, because here not only the length is changing, if only the length is changing, then R1 by R2 is equal to L1 by L2. But here it is not just the length is changing, but also your area of cross section is reducing. So whenever both length and cross sectional area changes, then R1 by R2 is equal to L1 square by L2 square. This is a very, very important relationship. So R1 by R2 is equal to L1 by L2 square. We will use this equation here. We know that R1 is equal to 1, R2 we need to find out, and L1 is equal to L. My final length is equal to 2L. So L1 by L2 is equal to L divided by 2L whole square. That is equal to L gets cancelled. So 1 by 2 whole square. 2 square is equal to 4. So when I cross multiply this, so I will get R1, R2 is equal to 2L.